Okay, so we are moving on into Unit 7, which is polynomials. And I have to tell you, this is actually my favorite unit of Algebra 1 or 2. I think it's just kind of a fun unit, and I think a lot of it is pretty logical and makes sense. And once you get the hang of it, all of it should just kind of be easy and fit together nicely for you. So, first notes we're going to work on are adding and subtracting polynomials. And as soon as you see that word polynomial, it sounds really scientific and mathy, but when we get down to actually what it is, it's not going to be so intimidating. So let's start with a monomial. So a monomial is an algebraic expression consisting of one term. Okay. And when I say one term, I mean something that looks like 3x, negative 5, 1/4 y, something like that, okay? It can have as many variables attached to it as it needs to have, but it can be a multiplication or a division problem, like these two are, but cannot have an addition subtraction. You'll see why in a minute. So the degree of a polynomial is always the exponent, the largest exponent that it has. So monomials, mono means one, so that is always going to be to the first, y to the first. You only have one of them, so that degree is always going to be 1. Okay. Polynomials, so poly means many. Okay, so it's exactly the same as a monomial, but instead of having only one term, it has many terms. Usually if it has two, we will call it a binomial. If it has 3 terms, let me put terms in there for you. If it has 3 terms, think of what you might think that would be called. A 2-wheeled bike is called a bicycle. If it has 3 wheels, we call it a tricycle. So 3 terms would be called a trinomial. Anything after trinomial, we really just lump into the polynomial category. Okay, so 4 plus terms, 4 and above, we would call a polynomial. Okay, so standard form of any polynomial is where the degrees are, or the exponents, which are the exponents, are listed in descending order, meaning they're going down. Descend. Descending order. Okay. The coefficient of the first term is called the leading coefficient. So for example, let's say that I wrote, I'm going to do a trinomial. So I'll call it 3x squared plus 7x minus 5. So the degree of this polynomial would be 2. It has 3 terms. We've already seen ones like this in our quadratics unit. So it has 1, 2, 3 terms. They are separated by addition or subtraction. And then the leading coefficient, we'll just call that the LC, leading coefficient, is that number that adds out in front. Okay. So for this one, let's put it in standard form, and we're going to name those 3 things right there. The degree, I'm going to add the terms in there also, and the leading coefficient. So you want to start with the exponents. Remember that if it does not have an exponent showing, we always assume that to be 1. The constant is really negative 2x to the 0. And when is anything to the 0 power? Well, that's 1. Negative 2 times 1 is negative 2. So if I were to list this in descending order to put it in standard form, and remember the sign comes with that term. So whatever sign is in front. So I'm going to put my x cubed first, then x to the second. So it'll be 3x to the second. Then my x to the first, and then my constant. So my degree of this is the largest exponent, which would be 3. I have, in this case, I have 1, 2, 3, 4 terms. you're going to notice that every time you count the number of terms, it's exactly one more than your degree, and that's because you have this constant down here that's really x to the 0. You always have that constant added on. Even when there's nothing showing there, the constant would be 0. Okay, and then the leading coefficient would be that number right in front, and that would be 4. So, like we said before, so a monomial means one term. An example of that would be negative 5x. Binomial means two terms. And you've seen these quite a bit. If you had something like 3x plus 7. And a trinomial is very similar to what we saw in quadratics. It would be something like x squared plus 5x plus 6. Oops, let me scoot that up. Sorry about that. Okay, so adding and subtracting polynomials. This is what I call in and out math, meaning in and out burger. So I want you to think about when you go to in and out. If you go to in and out, you usually order either a single or a double-double. But then in and out also has a secret menu where you can order 3x3s and 4x4s, right? So if we let's call x's will be our singles, and x squareds, because they have two patties, will be our double-doubles. Okay. And then let's say a 3x3 would be an x cubed. And then if we did a 4x4, that would be an x to the 4th, right? Okay. Let's spread that 3x3 out so it doesn't look like 3x cubed. Okay. So if you've been to in and out before, that kind of makes sense to you. So what really is going on is that you're just adding up what you're buying at in and out, and we can say that the constant, let's say those are milkshakes or fries. Let's say they're fries. Okay. So you can add polynomials, add and subtract polynomials horizontally. I prefer to add them vertically because I think it makes more sense, but let's go ahead and do both. So horizontally, I'm going to add up all of my 3x3s first. So I've got 5 3x3s over here and 3 3x3s over here. So I've got 5x cubed plus 3x cubed. Then since I'm going to go in descending order, I'm going to put my double-doubles, and I've got 2 of those. Then I'm going to put my singles, and I've got 5x and negative 3x. And then I have 2 french fries. So if I just want to total up all the things that I bought, then I would have, how many 3x3s would I have? I would have 5, then I bought 3 more, so I would have 8 3x3s. But they're 3x3s. So a really common mistake, one of the reasons I started teaching this, a really common mistake with polynomials is that people will add these exponents together. But if we remember our exponent rules, the only time we add those exponents together is when we've got multiplication going on. We have addition going on here, so it's a completely different set of rules for that. You're simply adding up the coefficients. That's all you have to do. All we've got is 2 double-doubles. Singles, we had 5, and then somebody ate 3 of them. So now we only have 2 left, and we have 2 fries. So you have it in standard form, descending order of exponents, and total. All you did was add your coefficients. Should be easy. Okay, I'm going to do the subtracting polynomials, and this is where I will use, actually let me do this one again, and I'll do it in vertical method. Okay. So if we were to write out what we had 5x cubed, and I'm going to put a little space saver in here. In this first one, I don't have any x squareds, but I'm going to put a 0 there just to help it along. Okay, and then I've got 3x cubed, 2x squared, and 5x. And I don't have a constant, so I'm going to put that there to add that along. So if we do that, oops, that's a cubed. Now you're really just bringing down the different types that you have. So you have 3x3s, double-doubles, singles, and constants. Now you're just adding up. Plus 2, 5 minus 3 is 2, 2 plus nothing is 2, and 5 plus 3 is 8. And you end up with the same answer. So vertically or horizontally, that's a personal preference, and I'm going to let you decide that for yourself. On subtracting polynomials, I want you to think about another word that we've used for negative. And what we usually say is that negative means the opposite. Okay. So when you're subtracting something, you're actually taking away or doing the opposite of what these are. So I'm going to write this one out in vertical method because that's really the way I prefer. Minus 3x, and I'm going to put a plus 0. The only terms I have here are x to the 5th, x to the 1st, and constants. So I'm just going to make sure I've got those three. When you are subtracting this entire parentheses, it's like you are multiplying that second parentheses by negative 1. So all of these signs are going to reverse. So what I do is say, okay, well that's a negative negative, which gives me a positive. A negative positive gives me a negative 2x, and a negative negative gives me a positive 5. So if you look at what you started with here and what we ended up with down here, all of the signs have just been reversed. Going from negative 4x to the 5th to positive 2x to negative 2x, and negative 5 to positive 5. Once you've got that done, now again, you're just adding up. So I've got 10x to the 5th minus 5x plus 5. Okay. Good. Just a couple more. All right, so actually, I'm going to do this one more with you, and then I'm going to have you try number 1 and 2 on your own. So I usually kind of see what I've got going on here and see what terms I have. So here I've got an x cubed, an x, and a constant. Here I have an x squared. Here I've got kind of a mish of everything. So I've got x cubes, I've got x squares, I've got x's, I've got constants. So I'm just going to make a space for everything. So I'm going to bring this first one down. I've got 5x cubed. I don't have any x squareds. So I'm just going to make a space for it, minus 2x plus 1. This I know I need to flip because of that subtraction. I need to flip those signs. So I'm going to end up with negative 2x squared. I don't have any x cubes. And make that a negative 4x. And I don't have any constants. Then I have an x cubed. Now that is adding that polynomial. So that's like a 1 plus 5x squared minus 8x plus 0. So really the ones you really need to be concerned about are the subtraction. And you must remember to flip your signs in that parenthesis only the one that's directly next to it. Because essentially what it's doing is like you're multiplying negative 1 times 2x squared plus 4x. Okay, that's what that's doing. So now you can just bring your, I call them labels sometimes, your terms down, and then just add straight up and down. So 5 plus 0 plus 1 is 6. 5 minus 2 is positive 3. Negative 2 plus negative 4 is negative 6. Minus 8 is negative 14x. And 1 plus 0 plus 0 is 1. All right, go ahead and try number 1 and 2 on your own, and then come back and check your work. Okay, how'd you do? Great job. We'll do lots in class. Thanks.